Okay, student, this is the exercise 15.1 from the Harvard Anton book, and topic is obviously topics in the vector calculus. So we are starting here from as according to your course outline is exercise 15.1 is 17 to 24. Okay, in the last class we have done the divergence of f and curl of f, and now in this class we will discuss about the gradient dot f cross g. Okay, and this is your class course outline, and now I make here the question statement. It's up to you that maybe. Okay, fine, I think so today I have solved the question number 24 here. Okay, fine.
मैम
Yes.
मैम आपने जो पिछली क्लासेस हुई थी उनकी रिकॉर्डिंग नहीं शेयर की अभी तक।
ओके, ठीक है, वो मैं आपके साथ, ओके फाइन, अभी मैं आप लोगों के साथ एग्जैक्टली शेयर कर देती हूँ. ठीक है. After this class, at after 11 o'clock today, I will share the class videos, recorded videos. Okay. Okay, student. Question
थैंक यू
number
मैम।
24. Find the gradient dot f cross g. Okay. Of the question is if there is the f of xyz is equal to yzi plus xzj plus xyk. Okay, and second is f of x y z, g of x y z is equal to x y j plus x y z and k. Okay, these are the, now we have to solve solution. In solution, student, for the for example, we write here that given is f of x y z is equal to yzi plus xzj plus xyk. And in g of xyz is equal to xyj plus xyzk. Okay. These are the values. Okay, I can write here the equation number 1, and this is the equation number 2. And the value of the gradient is equal to partial by partial xi plus partial by partial yj plus partial by partial zk. This is the equation number 3. Okay, now we have to find the gradient dot f cross g. For this purpose, we have to use like a determinant like a scalar triple product. Scalar triple product value is always like a its answer will be like in a scalar quantity. There is not the direction, there is no vector in answer. There will be the only scalar triple product. In scalar triple product, we find the only scalar quantity. Just okay, fine. Now, student, I will take the determinant like this way. In the f, for example, if I have to find the f cross g, then I've on the first row I write here the ijk, but now there are the three vectors. That's why on the first I will write here the partial by partial x gradient coefficients, and partial by partial y, partial by partial z. And in the second row I put the value of the f y z. I will not mention here. And in the xz, and in third one is xy, and at the last is xy, and no, sorry, 0. Value of the I there is not shown in the g of xyz. That's why I is 0, and xy is j, and y is xyz is k. Okay, these are the values of f cross g. And now As usual, I have to take the determinant of the three values. So there is the plus sign, minus, and plus. Okay. Now, student, I have to hide this row and this column. So partial by partial x and positive value with positive value of xz into xyz minus this value minus this value. Okay. Minus xy multiplied by xy. Okay. Similarly, minus j minus, sorry, j, no value, minus partial by partial y into, I have to hide this row and column. Then I find yz, xyz, yz multiplied by xyz and minus xy into 0. Okay, so this column is a minus xy multiplied by 0. And then the last value is partial by partial z. And I hide the row and the column. And then I find yz multiplied by xy minus 0 multiplied by xz. Okay. Then afterward, I find its value is partial by partial x of x square yz square minus x square y square minus partial by partial y into x y square z square minus 0 plus partial by partial z into x y square z minus 0. Okay. Now I have to take the derivative according to this is. So taking the derivative of x square yz is 2x raised power 2 minus 1 and y value and this value is z square minus again taking derivative of x square partial by partial x of x square. So 2x y square, okay, power 2 minus 1. This is the value of the, but I also use the brackets because if there is a different sign which is multiplied by according to this, then okay. Now x y square z square, so its value is 2x y raised power 2 minus 1 z and 0 value is 0 plus partial by partial z, it means x y square into 1. This value is. Now I also remove the brackets. 2x y z square minus 2xy square minus 2xyz and plus xy square. That is the results of the gradient dot f cross g. Okay. Okay, student, also you notice that there is not the value of the any I, j, k values. Okay. Um, I also check one time here. Yes. Um, from the start, okay. You can take also these questions, student, okay. That what we have done in the exercise 15.1, we have done the question number 24. Find the gradient dot f cross g. So f g values are these, okay, and gradient dot f cross g, in that gradient f g are given, and we know that, okay, it means that we already know that what is the value of the gradient. So gradient is partial by partial xi plus these values. So gradient dot f cross g values are like this way, that in first row we put here the gradient coefficients, and in second row we put here the f coefficients, and in the third row we put here the coefficients of the g. And then we use the scalar triple product uh, according to the, by taking the determinant, okay. This is the exercise 15.1 is complete. Now we are going to start the exercise 14.1. Okay, now further outline is exercise 14.1. Question number 1 to 16 plus examples. Okay, I also mention here exercise 14.1, question 1 to 16 plus examples. Okay, I also try of one of them. Okay, student. What is the exercise 14, chapter number 14? I think so. It is related about the integration, double and triple integration. Multiple integrals. It is related to multiple integral. Okay, student. This is the chapter number 14.1. This is basically I start from the chapter number 14 by, okay, this is related to multiple integrals. There is the double integral and triple integral in this chapter. Okay, basically that is the related to the volume. Okay, what is the integration? Integration is the area under the curve. And area is denoted by, in 2D, it is denoted by dA. Okay, volume, basically volume. Okay, in the double integral, that is equal to the volume of the area, and here we have to find the double integral, and there is a dA means x dx dy. Okay. Okay, for example, exercise is example number 1 is in front of you, student. 0 to 1 integration x y square dx. Okay, then you have to take the integration like this way, because there is the variable is x. So that's why y square is the constant. So y square is outside from the integration. And now then take the integration 0 to 1 x into dx. Then integration of x is, in the integration there is the addition of the power in the uh, power of the variable, and also in denominator value should be the same That was the which was the value of the power of the variable. So y square is this is, and this its power is x raised power 1 plus 1 x square, and square 2 values also in the denominator. Okay, that is x0 to 1. Applying the values. Okay, applying the limits. For example, I write here something. Basically, what is the integration? Integration of x is x dx. So its integration would be 1 plus 1 over 1 plus 1 plus constant. And if that is equal to x square over 2 plus constant. But if there is application of the apply of the limit, then c word will not be, c will not appear here. Okay. So its value is basically y x square by 2, then applying the limit, after applying the limit, y square by 2 into 1, okay, 1 square minus y square into 0 square by 2. Okay, this is the basically value. So its result is y square by 2 minus 0. 0 over 2 is 0. So this is the result, that y square by 2. Okay. And if similarly, if we find the area integration with respect to dy, so x y square dy. So x 0 to 1. X is basically a constant, so it should be in the side way. And this is the y square 0 to 1 y square dy. So its result is y cube over 3. Integration of the y square is y raised power 2 plus 1 over in the denominator 2 plus 1. So y cube over 3 and xy cube over 3. So after applying the limit, you check, student, that x over 3 means like this way. After applying the limit, x into 1 cube over 3 minus x into 0 cube over 3. So this is its result is x cube into 1 cube is only one value. So x over 3 minus 0. Its result is x over 3. That is the related to this is. Okay. Now this is the integration of the different variables. Now I will in the iterated repeated integration, the iterated integrals is shown like this way, that there is shown the two limits, okay, a to b, c to d, f of x, y, and a to b limit is for dx, and c to d limit is for dy. And for combining, after combining dx, dy, it is equal to dA, okay. So evaluate the example, evaluate 1 to 3, 2 to 4 into 40 minus 2xy into dy dx. That is the first part. And this is the second part of the double integration. 2 to 4, 1 to 3, 40 minus 2xy dx dy. For example, 1 to 3, 2 to 4, 40 minus 2xy dy dx. So 1 to 3 and 2 to 4, 40 minus 2xy into dy dx. Okay. First of all, student, you take the integration of with respect to y. Okay. The inner derivative you have to take the first. Okay. For example, here you notice that this is the dx dy. Okay. But now in the, if there is the value of the dy dx, the inner derivative, inner integration firstly we have to apply. Okay, you notice here that the bracket is on the dx variable. That's why we have to first integration with respect to dx. And in the second one, you notice that in the inner value is dy, not dx. So bracket would be in the variable of dy. So evaluate 1 to 3, 2 to 4, 40 minus 2xy into dy dx. So we firstly derivative of the dy first as this 1 to 3 integration, and then 2 to 4, 40 minus 2xy into dy. there is the closed value in the brackets. So in the outward value is dx. So first of all, we will take the derivative of the integration of the y variable. So 40 integration of the 40, 1 integration of the 1 is y. So 40 into integration of 1 is 40y minus 2xy. So 2xy is the basically the x and y square by 2. For example, if there is the missing of the one step I mentioned here. Okay. 1 to 3 integration with respect to y, that is equal to 40y minus 2x y raised power 1 plus 1 over 1 plus 1. Okay. This is basically into dx. Now you can look here that is 1 to 3, 40y minus 2 over 2. Okay, one step more. I think I have to solve here. That is equal to 1 to 3, 40y minus 2xy square by 2 into dx. So 2 and 2 values are cancelled. And now its answer is 40y minus xy square into 2 to 4. Okay. Okay, after taking the integration, student, there should be the line of this way, like slash, and this applying the limit should be there, 2 to 4, like this way, student. Okay, now then upper limit is applying on the first time, that is 40 into 4 minus in the space of the y. Okay, not in the space of x, because there was the integration of y. So we will put the value of the upper limit and then lower limit on the value of the on space of the y. Okay, minus x into 4 square. I think so. I have right here this line. Now I step here like this way. That 1, 2, 3. And now I apply the upper limit, 40 into 4 minus x into 4 square. This is the first limit minus now second lower limit is 2. So 40 into 2 minus x into 2 square. Okay, now I also apply this. And now there is the combined bracket into dx. Okay. Now you notice that afterward with this here, 40 into 4 is 160 minus 4 square is 16x minus in bracket 40 into 2 is 80 and minus 2 square is 4, so minus 4x. So 1 to 3, 160 minus 16x minus into 80 minus 4x. So 160 minus 80 is 80 and minus 16 minus 4x, again its value is minus 16 minus into minus plus minus 16 plus 4x is minus 12 dx. Okay, after it apply integration with respect to x. So its result is 80x minus 12x square by 2. Okay, there is the power is 1 plus 1 and in also in the denominator is 1 plus 1. And I also apply, there is not the sign of the plus c. Okay, plus constant will not there. In the definite or indefinite integral is that when a limit is applying, then there will not c value. So here use here we like this slash, and this is the limit, lower limit, and this is the upper limit. Now apply the upper limit and then lower limit afterward. Two ones are two and two six are. Okay, after notice that 80x minus 6x square. Okay, after cutting we find it this value. Now applying the limit, I step here. 80 is equal to 80 into 3 minus 6 into 3 square and minus 80 into 1 minus 6 into 1 square. So 80 into 3 by calculation, if I calculate 240 minus 3 3s are 9, 9 6 are 54 minus 80 minus and minus is plus 6. Okay, now after calculation, we will find this result 112. Okay. Okay, these are the exercises that is related to the double integration. Okay. Exercise 14 point, example is 14.1 is example number 1, 2. Students, similarly, we find the basically area according to the x and in the y direction. For example, in physically, you notice there that these are the x values of a area under the curve. Basically, that is the integration. Okay. So we have to also consider according to x-axis and according to y-axis. That what value in that is the 3D surface. Okay, I also will show here the. Okay, student. For example, these are other examples. This is the example. Example number 3. In example number 3, use a double integral to find the value of the solid that is bounded above by the plane z is equal to 4 minus x minus y and below by the rectangle 0 to 1 and cross 0 to 2. Okay, basically this is equal to limits. These are the limits of the x into 0 to 1. Okay, and that is the value of the y 0 to 2. These are the limits of the x 0 to 1 and 0 to 1. Basically, you write here the these, and that is your function. Okay, use a double integral. Look at the figure also, that in the x-axis, the just like the student, in the x values are 1 to 2. Okay, and y values are 1 to 2 in the in 3 dimension. Okay, this is the x, this is the y, and this is z. This in the area is in the lower limit is 1 to 2. Okay, these values are 1 to this, basically this point 1 to 2, and this is the. Okay, fine. And the second point is on the x-axis. uh, Wait, student, control. 0 to 1 and 0 to 2. Okay, 0 to 1 and 0 to 2. Okay, and basically by joining these points, because this is the basically this is the limit of the x-axis 0 to 1 and this is the y-axis limit 0 to 2, but also make the some rectangle there should be um, under the uh, curve, under the z, under the plane z is equal to 4 minus x minus y. So this point we have to join. बेसिकली आपने ना इसके एक डायग्राम जनरेट करनी है, सिर्फ पॉइंट्स, कॉर्नर पॉइंट्स आपको मिल गए, ठीक है, ओके फाइन. दिस इज द 0 to 1 x points, and these are the points of the 0 to 2, but there should be make a rectangle. Okay, that is the by joining the points is the 1 and 2, we find here the one rectangle form. Okay, the volume is the double integral of z is equal to 4 minus xy. Okay, basically this is the volume. Z is equal to of the plane, z is equal to 4 minus x minus y over region R using the theorem. Okay, 0 to 1, 0 to 2 into 4x, that is the f of z value, that is equal to 4 minus x minus y. That should be the given. Okay, and the first dx dy, so dx limit is according to this 0 to 1 and dy limit is 0 to 2. Okay, this is the v is equal to double integral region means the limits. Okay, if there is not write the limits, we can also write here the r value region, 4 minus xy into dA. Okay, basically dx dy is also known as the dA. Okay, now you have separately first in the volume you have to first write this way, that basically you have to write the volume formula is v is equal to double integral r z into dA. Okay, z value is 4 minus x minus y and dA value is dx dy, and r are the separate limits of the integration. In the inner value is dx 0 to 1 and then dy 0 to 2. Okay, now integration with respect to x, right? So 4x minus and this value is x square by 2, power is 1 plus 1 over in the denominator plus 1 plus 1 minus, basically this value is y. So if we take the integration with respect to x, then there should be minus xy. Okay, then applying the limits 1 to 0. Okay, so applying the value of the x here in the only in the x, not in the y. Okay, because we have to take the integration with respect to x. So 4x minus x square by 2 minus xy, after applying the limit of 1, 1 means 4, 4 into 1, 4 minus 1 square is 1. 4 minus 1 by 2. Okay, minus 4 minus 1 by 2 is basically 7 by 2. Okay, by taking the LCM, and x value is 1, so minus y. Okay, 1 into y is minus y, and then integration with respect to we take the value y. For example, its integration is 7 by 2 y minus y raised power 1 plus 1 over 1 plus 1, so y square by 2, and after applying its limit is 7 by 2 into 2 minus upper limit, first of all upper limit minus 2 square over 2 minus 7 by 2 into 0 minus 0 square by 2. So its limit is 2 is cancelled with this is minus, 2 is cancelled with this is 7 minus 2 minus 0 minus 0. So its result is 5 minus 0, that is equal to 5. That is your required result. Okay, student. Any questions, student? Example number 3 is this time I have done. Okay, how many examples are just like student, you notice here that also over the rectangle R. Okay, that is the z value, z is y square x, and dA is dx dy. Dx values are minus 3 to 2 and dy is 0 to 1. Okay, minus 3 to 2 and 0 to 1. Then according to this, for example, I also noticed that what are the properties of the double integral. Means if there is the value of the constant is multiplying, then constant will be value will be the same, will be the cited. Okay, and f plus g, then we can separate, add it, that integration of the f first plus integration of the second values, and similarly behavior with the minus x in it. Okay. These are there if there are two regions. Okay. Just like it's in this diagram, that there is the one region and there is a two region, then their limits should be the breakup. Okay. Limit would be the same, but also there is the interval. Then okay. That is the example number 14.1 is example 4 is only last example. Then exercise 14.1 will be start. Evaluate the double integral. Okay. Student, you have to take just y square x into dA. So 0 to 1 and minus 3 to 2 y square x. Okay. According to this is we have the set the values. X values are minus 3 to 2 and y values are 0 to 1. So minus 3 to 2, 0 to 1, y square x. First integration with respect to x. Okay. Y square x square by 2. Okay. And then applying the limits. Afterward, finally, we find it minus 5 by 5 by 2 y square. And then integration with respect to x, y. So we find it. Okay, student.